Hi everyone, I'm Jammie Maquilan together with
Suzzie Olivar, and I am one of the reporters for today.
and now we are going to discuss the optimization problem and provide some problem-solving examples and the real-world application of optimization problem. So what are the key concepts of optimization problem? First, let's define the optimization problem. Now, what is the significance of optimization problem? Optimization problem is highly significant, especially in real-life applications, such as real-world application, efficiency and resource management, decision-making and planning, mathematical modeling, and preparation for advanced concepts. In real-world applications, optimization problems can be used to optimize production processes, minimize costs, maximize profits, optimize resource allocation, and solve various engineering and scientific problems. Optimization problem is also significant to efficiency and resource management, as it helps in maximizing efficiency by finding the optimal values of decision variables. This also allows for an efficient allocation and utilization of limited resources such as time, money, materials, or manpower. Decision-making and planning, as it provides a quantitative framework for decision-making and planning. So by formulating a problem mathematically and optimizing a objective function, decision makers can identify the best possible solution among different alternatives. Mathematical modeling. Optimization problems require the formulation of mathematical models that represent real-world situations. So this process involves translating real-world problems into mathematical equations, which enhances problem-solving skills and mathematical modeling abilities. Preparation for advanced concepts. Basic calculus optimization problems serve as a foundation for more advanced optimization techniques and concepts. So they provide the necessary understanding of mathematical optimization principles, which are essential for tackling more complex optimization problems in various fields such as nonlinear programming, linear programming, and dynamic programming.
So good day, Miss. Today I'm going to provide the examples for the optimization problems. So this is our first example. So find two real numbers where sum is 50 such that their product is maximum. Then let x be the first number and let y be the second number. So first let us identify let us identify our working equations. So first is the x plus y equals to t. But dili dyan siya mao atong gamitin nga equation or our main equation, because ang atong gipangita is the maximum product. So which means multiplication ang atong gamiton. So x times y equals to t, the product. So to start, ato ni siyang i-use, pero mahimon na ni siyang y equals to t, then transpose x, mayroon siyang negative x. Then next is substitute ni sa y. So x open parenthesis 50 minus x, then close parenthesis equals to yun na siya. Then next is multiply x times 50, 50x, then x times negative x is negative x squared. Then next we are going to find the critical numbers. Para makuha na nato, mahitaw na to ang first derivative sa p. So first derivative sa p over I in respect to x equals to 50. Ang derivative sa 50x is 50. Then derivative sa negative x squared is, ang derivative sa x squared is 2x. Now follow the sign. The next, para to find the critical number, i-mode siya na to og 0. Equate na to siya og 0. So 0 equals to 50 minus 2x. The next, let us transpose 2x to the left. So 2x, mayroon na siya positive 2x equals to 50. So para mabili na lang si x,
Divide 2 from both sides.
2 cancel 2x is equals to 50. So x is equals to 25. Only siya nga ng x. Kaya 50 divided by 2 is 25. So next, let us find our second number, which is the y. So to get the y, let us use this equation. So y is equals to 50. Then substitute the x, which is 25. So y is equals to 25. So kay 50 minus 25 is equals 25. That is our y. Next is, let us multiply the x and the y. X times y is equals to p. So 25 times 25. 25 times 25 is equals to 625. Okay. So to check if mabalik siya ang maximum product, so mangita tag another number na ang sum is 50. For example, 40 10 is equals to 400. So kay maximum product na lagi pangita, nya mas dako man si 625. So this is the answer. This is check. So this is our second example. So our second example is the sum of the two non-negative numbers is 10. Find the minimum sum of cubes of two numbers. So same last time, let x be the first number and let y be the second number. Then let us find our working equations or identify. So first, magamit gihapon ta x plus y equals to 10. So dili gyapon ni mao ang ato ang main equation nga gamiton. So identify sa ta. So the sum of two non-negative numbers is 10. So we will consider positive values na ang sum is 10 kay non-negative man daw, non-negative numbers. Then find the minimum sum of cubes of two numbers. So if I let x cube and y cube, ang sum daw nila is dapat minimum. So ikaw na to siya s for the sum. And after, let us use this. Y is equals to 10. Substitute x to the right side. Meron siyang negative x. Then after substitute, x cubed plus 10 minus x cubed equals to s. After, let us find the critical numbers, and to find the critical numbers, let us find the derivatives of s. So derivative of s in respect to x is equal to, so the derivatives of x cubed is 3x squared. Then to get the derivatives of 10 minus x cubed is, let us use the chain rule. So it is positive 3, then copy 10 minus x, then minusan ang exponent of 1, meron siyang square. Then the derivatives of 10 minus x is negative 1. So to get the critical number, equate this into 0. 0 is equals 3x squared, then combined, meron siyang negative 3, then copy 10 minus x squared. So para mapadali pa ni siya distribute, let us multiply 1/3 in each side. So 1/3 times 0 is equals to 0. 1/3 times 3x squared, cancel the 3, equals to x squared. Then 1/3 multiplied to negative 3, 10 minus x squared, cancel sad balik c, ay makancel na po si t. So may mo siyang negative 10 minus x squared. May mo siyang t. Then, may square root of binomial man siya, ato siyang i-expand. So, it is a square root of binomial, let us expand. 10 times 10 is equals to 100. Then 10 times negative x times 2 is negative 20x. Then negative x squared, positive x squared. Then after, distribute the negative sign. Distribute negative times negative, positive. Negative times positive equals negative. Then cancel x squared, combine like terms. Then the number negative 100 plus 20x. Transpose negative 100 to the left side, it will be positive 100 equals 20x. Then, let us divide 20x on both sides para may bili na lang si x during a side. Cancel 20, and the answer is 5. And 5. So this is our x. The next is, let us find our y. So to get the y, let us use this equation. Y is equals to 10. Substitute the x. The value of x is equals to 5. So y is equals to 5. So our y is also 5. So let's check. So 125, 5 cubed, 125 plus 5 cubed, 125 equals to 125 plus 125 is equals to 250. So this is sum of cubes of two numbers. So let's check if mao na ba jud niya ang minimum. So let's find another number example. Then 729 plus 1 is equals to 730. So, mas gamay masuto si 250. So, this is the final answer. Because ang atong gipangita is ang minimum. So, that's all.
So hey everyone, now we will be solving a real-world problem involving optimization. So here is our problem. A delivery company wants to come up with a package box that has a square base and a volume of 40 cubic feet. What should be the dimensions of the box with the least amount of material to be used? So in our problem statement, we are given a volume, so we're supposed to be using the formula of volume, which is length times width times height. But in our case, our problem states that a package box has a square base, so our volume formula became x squared times y. According to the given problem, the volume of the package box is 40 cubic feet. So we'll just replace the volume into its value, which is 40, and then multiply it by 1 over x squared in order for us to get the value of y. After that, we have to look for the surface area of the package box in order for us to proceed in applying derivatives in our equation. So now we have the surface area equals 2x plus 4xy. The next thing we're gonna do is substitution, where we substitute the value of y, which is the 40 over x squared, and then we simplify it. So now we have 2x plus 4x multiplied by 40 over x squared. Then, as we now only have one variable, which is x, we can finally find or apply the derivatives in our equation. So now we have a prime 4x minus 160x to the power of negative 2. Next, we will equate our equation to 0 for us to simplify the equation and find the value of x. Now, what we're gonna do is to multiply the equation by x squared in order to cancel the x on 160 over x squared. So now we have 4x cubed over 4 equals to 160 over 4. And then we will find the square root of both equations, so the cube will get cancelled, and then we can finally get the value of x. So now we have the value of x, which is 3.42. Now we have to look and apply the second derivative test in order for us to check whether our x value is the maximum or the minimum. Using the first derivative prime, we have to find then apply second derivative. So now we have a double prime equals to 4 plus 320 over x cubed. Next, we replace the value of x next to the double prime and then also substitute the x value to the other side of equation. So now we have the double prime of 3.42, which is 12. And based from our findings, we have determined that the value of x, which is 3.42, is the local or relative minimum because 12 is higher than 3.42. Now, the last thing we're gonna do is to substitute the minimum value, which is 3.42, to the equation of y. Now we have here 40 over x squared, which will become 40 over 3.42 squared. And there we have simplified this equation, and now we have the value of y, which is 3.42. Thus, the dimension of the box with the least amount of material to be used is 3.42 feet times 3.42 feet times 3.42 feet. And that's all for the real world problem, applying the optimization problem. And thank you for listening.